So we had this quadrilateral. It's fine. It's fine. It's fine. Then we took the midpoint. And this time the midpoint seems to be coming this side. So I will take it this side. A, B, C, B, C, D. And so initially the this was it doesn't which one was X? This one, right? Parallel to BD and parallel to AC, maybe that will call Y. And wait, yeah, this one is Y is on the midpoint of this, right? And then they are meeting at O. Okay, and here we have the midpoints P, Q, so APOS is APXS. If I'm wrong, just tell me if this is the question, right? APOX, APXS, right? APXS. So Ishana, can you explain how we did this thing, this part?
Yes, sir. In the quadrilaterals APXS and APOS, we first subtracted the area of APS because it's common in both.
Perfect.
Then we know that SP is parallel to BD. And so SP will also be parallel to XO.
Yeah, and upon something not clear, you have to ask. SP is parallel to XO. Why is that?
Because BD and XO are parallel.
BD and XO are parallel. That is by the definition, the way of drawing the line X parallel to BD. Okay. Go on.
So since SP and XO are parallel, when we draw the altitude of the triangles SPO and SPX, it will be equal. And it also has a common base, which is SP. So since the base and height are equal, the two triangles SPO and SPX will have equal area.
SPO. Yeah, SPO, and this area is equal to SPX. SPX. Fine. Okay. Yeah. All right. So I assume it's fine. Now let's move to the next part. Yeah. Yeah. In the next part, maybe I'll just write it like this. And this is because this is the way I'm seeing that it really speaks in a way. Okay. That it is 1/4 of the total area. This speaks more to me because it's showing that, so showing that like this, right? That APOS, let's say for example, is equal to SORD. Am I correct? That seems a little, I don't know how to do that. That's yeah. See, I don't know how to do that. However, when I'm told that prove that all four are equal, then I'm told the full picture, then I get the idea of showing that it is, sorry, 1/4. And then the problem becomes like that, and that's more natural. My point of all this is I'll show that it is 1/4 of the total area. And that's what I'm trying to show. It's 1/4 of the total area. Or maybe APXS, it doesn't does it really matter? Let's see. Let's see if it matters. Or maybe let me not say X. Okay, I'll just say O. O is better, right? O is the more central thing. So anyone has made a progress in this? This is my approach. If any ideas? Okay. Okay. Tell me. So if this is the approach, let's say we are taking, then one thing comes out very clearly. Just like before, this APS is sort of separate, right? How would you relate the area of this? To what would you relate the area of this in terms of ratios? Well, there is I see only one natural thing relating it to ABD, and it's 1/4 of it. This is the only thing I see to do. Fine. Yeah, it is half in terms of length, and so it's 1/4 in terms of areas. Right. So now, what is the task? What is the problem reduced to? See, now we see this thing is that this ABCD, right? From ABD, we have taken 1/4 of ABD, right? Now we want to show that this SPO will have to be 1/4 of BCD. I mean, this is what we have to show. Is that
Yes.
right? And it doesn't look very bad, right? It doesn't look very strange in some way. Because you see, I just say this one, I won't say the whole thing. This is because now you want to forget the other things as long as they're not needed. And just look at SPO, right? And see. And then look at BCD. And SPO, you should try to see it as sort of a, shrunk version of BCD. So already one side is half. Along those lines. SP is half of BD. Is PO also half of BC? Is PO and BC parallel? No, right? What is parallel is PX and BC. PX and BC are parallel, is that fine?
Sir, how are they parallel?
Yeah. Anyone? P is the midpoint of AB. What about X?
Well, because both are midpoints, then you can,
Yes.
in triangle ACP, PX will be half of BC and it will be parallel.
Yeah, exactly. X is the midpoint of AC. Good. So we will maybe then you'll have to abandon O and come to X. That seems the more natural way now. What to do? I mean, if something works, then you have to go that way. Okay. Can't do anything. Okay, so SP is half of BD and PX is half of BC. No need to write this. You can just draw your separate picture. Yes, Nagesh?
Yeah, then they'll be similar.
Yes, they're
Right.
similar.
Just to-
Absolutely. So this SPX and DBC. Already we know that SP is parallel to BD and BX is parallel to AC. But obviously that is not enough. Is that enough to say they are similar? No. That just says that, yeah, I mean, I know they're similar and I know you guys understand it, but just saying and just trying to see it for myself in a certain tight way. So that says that these two angles are same, right? But then the ratio is also being told to you. If the ratio is not told, then you cannot say. You can draw this anyhow you want, this one X. So the ratio is same and so you can. And so it's, I mean, so it's half ratio in area, it's 1/4. Problem is done. Okay. So this other portion, SPX is also 1/4 of BCD. Okay. Rather SPX we have shown. So this is 1/4 of BCD and this is 1/4 of this. And so the sum will also be 1/4 of ABCD. You can just add it. I have just followed what looked natural, right? Anything tricky I did no, just followed what looked natural. Yes. So suppose now it's clear and to all of us, though Aparna you came late, but I think now it's okay for you this, right? Yeah. You have also put the some final touches. I believe it's fine. This XPX is parallel to. I did it in a slightly different way earlier. I was trying to I just showed that it is equal to this. I was bent on showing that, and that I saw in some. It's all same. Yeah, it's all same. So unfortunately, maybe then we'll just solve one problem today, okay? Because yeah, I want to strictly not go beyond the make it late. Otherwise, everything becomes bad later on. But yeah, it's a very wonderful problem, right? It is all 1/4 of each other. Right? Yeah, initially, but let's just talk about this a little bit. Initially, we also had this. So this is a trapezium, right? It's a trapezium. But is this cyclic? Is there a circle going through it? I don't think so. Right? There is no reason. Is it? So you see this px, yeah, you guys can see this px is half of bc. So notice this. Maybe I'll erase a few in this. Not. This px is half of bc. Right? Can you say anything about SO? Not so much, right? Maybe SY. SY is half of, or maybe no, maybe SX you can say, right? SX is half of DC, right? Can you see that? SX is half of DC. Right? So if we make BD and BC and DC equal, then they also become equal, right? Yeah. If we make BC and CD equal, then PX and SX become equal. Fine. Okay. But then it is impossible for PO and SO to also be equal, right? Because I mean, with one base, you are making one isosceles triangle, but that with the same height, can you make another isosceles triangle? That is absurd. That is not possible, right? Because when you make one isosceles triangle, it will be sort of the perpendicular, it will fall on the midpoint. Another one that you make with the same height, that is important, it will not fall. I mean, it will fall somewhere else and it cannot be. Okay. So, right. So if one of them is isosceles, the other one cannot be isosceles, right? So let's say that Px, so Px is equal to Sx situation we can create. Mhm. Right. But then in that case, we cannot have PO equal to, then PO will not be equal to SO. Okay. So is it possible then for them to be similar? At least in the traditional way, right? In PXS and POS, they cannot be similar anymore, right? Because PX by SX, the ratio is 1. They are isosceles. But PO by SO, it cannot be 1. So it's not isosceles. So you can create situations in which they are not similar. In this sense, I mean, there are still other possibilities, but okay. Yeah, but obviously it can, yeah, it doesn't mean that it is not cyclic. So can we think of why it is not cyclic? Because, okay, so we can create a situation where Px is equal to Sx. Yes, I'll tell you. Px is equal to Sx is one situation, right? We can create that situation, right? But you see, this Sx, can it be equal to SO? No, right? Sx cannot be equal to SO. Okay. So in this situation where Px is equal to Sx, we cannot have Px equal to SO. Okay, so now let me just zoom out a little bit and say why this is useful. We have a trapezium. This where the sides are not same. Sides are not same meaning where px is not equal to SO. We have created that situation where px is not equal to SO. Okay. Now the homework is to show that this kind of trapezium cannot be cyclic. Show that SPXO cannot be cyclic. Why I'm saying this? What I'm just saying simply is that if SPXO is a cyclic trapezium, if this is a cyclic trapezium, all I'm saying is that if this is a cyclic trapezium, then show that PX and SO are equal. That's the homework. And that's actually very standard. You'll find it in NCERT also, maybe. If you have a cyclic trapezium, then in fact it becomes an isosceles trapezium. That's homework. And from the property of cyclic quadrilateral, which I've discussed with Aparna and Ishana, and Nagesh, you can just see NCERT if you don't know, just the basic properties. Yeah? Then you can prove this. That cyclic trapezium means isosceles trapezium. Also, so this is a very probably trivial exercise. Cyclic rhombus implies square. Cyclic parallelogram implies a rectangle. All these very elementary things. Okay. So being cyclic is a very special thing. That's the point. Okay. So this is one side of the story. Yeah, there are other properties of this one, which the experience which allowed me to do this problem. Otherwise, I would have not been maybe able to do. But I would like to share one page, which I think some versions of it we had discussed with Ishana. I think that time Unab was also there, and we were but maybe we didn't do this one, this harder version. But I will show you the page now. You guys. And then you can try some problems from there and we can discuss next time. Yeah, there is this thing called carpet theorem, and try to follow this particular place where I'm taking you, because this is in a very minimal way. And yeah, carpet in a quadrilateral. Try to do this. I mean, you can do all. I'll be much happy if you tell me a few things from here. I don't know most of it, but I mean, don't know meaning obviously I want to try it with you. I don't, in that way we don't know anything because you don't remember everything. But I want you to try this one and don't look at the solution initially, but try this. You can, the question is almost clear. The question is this. Okay, you can read the question and you can try this. This also sort of, this is a wonderful thing in the sense that it divides, I believe, into 7 equal parts or something. Okay, three, or something. I mean, or there is something, maybe 5 equal parts. Yeah, you will try. It's very wonderful problem, and it's a similar. And others also you can try. Do have a look at this. It's Carpet's theorem, and it's this cut the knot. It's a very wonderful place, a very old place. Do it. Please do it. Okay, you will enjoy it. You will enjoy it. So just try it and then share a few with me. I maybe don't know carpet and exomas. Okay, we'll stop here then. I hope this was good, right? Good learning experience. And yeah, keep trying, try more, and we will have the next class. Should we have it on, is Friday better or? Okay, let's have the next class on Friday. Is it okay? Oh,
Yes.
Yes,
yeah,
sir.
let's have it on Friday. Otherwise, there's a long gap, right? So Friday, 9:30. It cannot be at 9. Friday, 9:30 p.m. That is fixed. We will do that class. and we see. Use the week, try to solve as many as you can. Okay, and okay then. Thank you. Bye. Good night.